Hey guys. First of all, thanks for attending my talk, towards the end of our conference. Today I'm going to talk about something we did last year to kind of bridge the gap between prototyping and productionalizing your deep learning workflows. So let's just get to it. We'll first talk about what makes Spark an awesome platform, what makes TensorFlow an awesome ecosystem. Then we'll move to some recent advancements in TensorFlow 2 and some extension libraries that have been added for Spark, so we can connect everything seamlessly. And this also kind of enables us to do distributed deep learning, right from Databricks notebooks, and you can pick GPU or CPU clusters. Finally, we would use MLFlow to kind of manage and version and move our models between staging and production. And finally, just to wrap up, we'll talk about a quick blueprint to enable this whole approach inside Spark streaming. So we can use Spark streaming with TensorFlow and the best of everything. Who is this talk for? This talk is basically for a small to medium data science team who kind of works end to end like ours, who needs a minimal approach. So especially in retail business, before we invest so much into research and spending time on building models, we have to actually prove to the business itself that this is a valuable endeavor, right? So this approach kind of helps us focus on that, building the initial model, then kind of putting it into test and quickly iterating and experimenting on the model and then build the next version. We have deep learning. Why do we need distributed deep learning, right? Especially in use cases like recommenders. It's very difficult for us to train a recommender model on a subset of data because it can have any, it will miss a lot of features because it's almost impossible to get some sample of your recommendation data set. So that means you need to work with huge big data clickstream data sets, and you need to build your deep learning models off of those data so that you can capture all of the preferences from your data. So which kind of makes it that we need distributed deep learning. We also need the capability to train on multiple nodes, multiple nodes with multiple GPUs or TPUs and all of those capabilities. So this kind of unlocks most of the deep learning applications. So the world is your oyster. You can build recommenders. You can use custom language models. You can use it for computer vision models and online recommendations, right? So quickly about us. So we are a Rugilt group. We have 2 e-commerce websites. We're primarily based in East Coast. We have rulala.com and guild.com. So we provide exclusive private sales for fashion products. So our inventory keeps changing daily, and we have sales going on multiple times a day. Our data science team is pretty close-knit. We work end-to-end from exploratory analysis to actually deploying models, monitoring everything, running A/B testing. So it's a whole shop that deals with the whole platform. So our primary pipelines are Spark. We use Databricks, and then we also have AWS-based pipelines to run single node machine learning jobs. So so as of last year, we wanted to look into building the next version of our deep learning models. So whenever you say next generation nowadays means deep learning, right? So we actually looked at TensorFlow, and we wanted to find a solution that can let us focus more on the research and the ML task and less of the MLOps itself. The first thing you will notice if you're looking at distributed TensorFlow code is the whole wall of Kubeflow code or how to set up your infrastructure and nodes and everything, which kind of scares you and discourages you from going down that path. So what did we do with this whole approach? We actually built a GRE-based personalization model, which kind of looks at the sequence of products in a user session, and then we kind of recommend what's next. So it's very similar to what the YouTube recommender does, but it's more tailored towards fashion. And we were able to convert our prototype to like production model in like less than 2 weeks. You'll see why. It's basically just adding 2 or 3 lines of code like in your initial prototype code. It proved like our members loved the deep learning recommendation. We actually had like a 25%, more than 25% lift in click-through rates in our email campaigns. So yeah, seeing that I'm at a Spark conference, I wouldn't spend too much time into like best things about Spark, but I will point out like some great features that makes it great. So Databricks Spark, it's an open source platform. You can write code in multiple languages. Pipelines on single node, structured, unstructured, nothing you haven't heard before. So something I really want to call out, like in the multiple languages part is like, it kind of gives you the flexibility to create like UDFs in one language and having someone else use it in another language. So as an example, you can see here like data engineers like creating UDFs in Python and just registering it into the Spark context, and then data analysts or like data scientists who primarily work with SQL can now just call that UDF directly. This is like an immensely powerful feature, and I don't hear a lot about it, but yeah, this kind of decouples the engineering part versus the analytics part. Pandas UDFs, recent advancements, but it's like it enables a lot of use cases like model inference, so you can actually load your deep learning model into a Pandas UDF and then actually use it for inference. Spark ML provides scalable implementations of most of the common ML libraries, everything from traditional regression trees, multilayer, perceptron to like text models like word2vector and TF-IDF. We have a few models, we have a few prediction jobs that uses the Spark ALS collaborative filtering to provide like personalization products. And it also integrates very well with like sklearn, XGBoost, TensorFlow, PyTorch, and a lot of the different ML frameworks out there. So now moving to TensorFlow world. So TensorFlow is the machine learning framework that's maintained and used within Google. It has like a very active community of developers, which is why I really like it, because you can always find answers for any of your questions on the GitHub or like Stack Overflow or anywhere. Something I really like about the TensorFlow version 2 is they have this core principle of progressive disclosure of complexity. In simple words, you don't throw someone off a cliff, but you gradually throw them off the cliff. You can choose your difficulty. Like when you start off with the TensorFlow 2, you can actually use the Keras APIs to just do fit and transform, and that's it. But if you want more control of your training stuff, you can actually dive a little bit deeper, and then you can get access to like certain features which kind of gives you the levers to like make it as complicated as needed. So TensorFlow has like an end-to-end machine learning pipeline, which is TFX. We'll talk a little bit about it. It has a lot of extension libraries, which kind of extends TensorFlow's capabilities. Like if you want to use it for reinforcement learning, if you want to use it for probabilistic programming, like they have a different library for all of that. Finally, like you can find amazing tutorials and guides on tensorflow.org, which kind of walks you through building any sort of deep learning models. So yeah, you can get documentations on computer vision models, autoencoders, and BERT models and everything. So it's all there in those links. I'll be honest, and that's how I learned most of this work. I don't know why it's making the noise. So yeah, TFRecords. TFRecords are the native format for TensorFlow. So basically, it's a binary format, and it's like it kind of provides high performance for reading and writing data from the models and feeding into the models. It is optimized for use with TFX, and it's like very effective in storing sequential records. So we'll get to why it's important, but let's finish the TensorFlow part. So TensorFlow data is the data APIs, which kind of deals with like loading and batching and shuffling and doing a bunch of stuff with the data set itself. So TF APIs actually provides like easy to use implementations for loading your data from files, loading it from S3 or like any persistent store. You can also read directly from TFRecords and then put it all into a data set, which you can then use to feed data into a model. It does a lot of great optimizations behind the scenes. So one nice example is prefetching. So basically, while your GPU is training on the forward and backward passes, you can actually use your CPU to preload all the data, right? You preload the next batch. So that's basically prefetching, and then you can use auto-tune, which kind of automatically tunes the batch size and things like that, which itself is another great feature. Distributor is TensorFlow's version of distributing your whole training. So it provides synchronous and asynchronous distributed training strategies. If you want to train on TPUs, you have a different strategy. And by default, any code you write in TensorFlow has this default strategy. So that means you're already in this, already using this strategy thing without even noticing, right? So that means if you want to stick to pure TensorFlow and TFX, and you want to set up your infrastructure, all you need to do to convert from your single node code to your distributed code is just adding these few lines of codes. Right, so you can see that in the first one, it's basically you're defining the strategy you need. So mirrored strategy is one you use for GPUs. So when you want to train on GPUs on multiple machines, that's what you use. But if you don't have a strategy, if you don't have a GPU, then you can just say use the default strategy, right? So that's it. That's all you need to convert your code to distributed in TensorFlow's land. We still haven't talked about how this integrates with Spark. We'll get to that. Right, so TFX is an end-to-end ML platform. So it's kind of, some of the things that it does is very similar to what we can do in Spark. But there are companies who uses end-to-end TensorFlow, and they don't have Spark in their pipelines. So you can see this is also from the TFX website, so you guys can go check it out. But yeah, you can start with your data preparations. It kind of generates statistics and schemas and everything about your data. So it kind of monitors the data and kind of monitors the drift and everything in the data. TF transform is something like transformers in Spark. Basically, you're transforming your data to features, right? So that's the library you would use for feature engineering if you want to use this whole pipeline. Finally, things I really like in this one, which we kind of use, is the TensorFlow model analysis. So model analysis kind of gives you tools to compare drift and drift in your data and your model and things like that. So it kind of lets you also monitor models that's in production. If it's not performing as you expect, you literally get an alert. Finally, TensorFlow serving is the TensorFlow's component, which kind of serves your deep learning model in a performant REST API. So it kind of deals with everything setting up your container and everything, and all you need to do is provide your model, and it'll be served behind an API. So if you want to build an online service, this is what you would be using. Good thing is most of this is now well integrated into MLFlow, so you can just click one button and you're all set up for serving. Yep, so we already talked about these. Yeah, and then TensorFlow serving also has Docker containers provided directly from Google. So they have different versions of TensorFlow serving. So specifically, if you're using any extension libraries, they might need custom build of TensorFlow serving, right? So most of them are online. You can just look it up. Docker Hub has most of these different flavors of this library. Another cool thing is because it's all Dockerized, you can now set up your own container service if you need, and then just deploy different containers and just put it behind a load balancer, and now you have a whole performant serving endpoint. So we talked a little bit about extension libraries. So extension libraries are things that are outside of the main TensorFlow repo, but it kind of extends the functionality of TensorFlow. We actually use this library called TFRecords, which kind of helps you build recommendation systems. So it kind of follows most of the common best practices to build recommender systems. So you would, again, see a lot of tutorials and guides on how to use this whole library. Yeah, so basically it provides wrappers for building a recommender system model. So you don't have to deal with like a lot of creating custom stuff for this. One key feature is it kind of exposes Google's scan and approximate nearest neighbor engine, which is kind of used for quick real-time lookups of vectors, right? So you provide a vector and then we're like, give me all the vectors that looks like this vector, right? So that's what scanin is. So scanin is exposed as a layer in TF-recommenders. So if you use TF-recommenders, you can just say tf.keras.layers.scanin, and then you can actually access that approximate nearest neighbor engine in your model itself. What that means is you can now also save a TensorFlow model with this index built in. So we use that to build like an online service. So we just load this model that we saved and then kind of does real-time quick inferences. Yeah, and as you go through the library, you'll see that it kind of gives you blueprints to build retrieval models, basically like narrowing down your products, like from your entire product list to like a few subset that you want to look at. And then you can build ranking models, which kind of narrows it further down from the list of thousands to like 10 products you want to show the customer, right? You can do like multitask. So if you want to make your model learn from different objective functions, like you want it to optimize on clicks, purchases, and then carts. So you get that model also. Some more extension libraries which are interesting we are actively exploring is like TF ranking, so which kind of lets you build learning to rank models. So another great library which kind of provides you with the most commonly used loss functions like pairwise, pointwise, and listwise, right? And gives you ranking metrics out of the box. So if you want to use NDCG or MRR, it's already in those libraries. TF agents, again, is very useful for building reinforcement learning agents. In our context, we are exploring this library to build like contextual bandits, so we can like learn different things in real time. Finally, finally, TF Hub is like a collection of pre-trained models. So if you're looking for like just using the BERT model in your neural network, all you need to do is just go to TF Hub, find this URL or the path to that model, and then that's it. You can just create a Keras layer, which is actually just going to download the whole BERT weights and everything, and then you can just use it directly in your model, which is again pretty cool. Like it's not just text. You can see like it has like image domain problems. It has video, audio. Most of the problems that are like people are actively researching, they kind of put it into like this TF Hub, and then you can just use it for your use cases. Yeah, finally, the next thing is MLFlow. So again, I wouldn't spend a lot of time here, but MLFlow lets you track your experiments, provides reproducibility, like deployability, so you can be sure that you're deploying the same thing or referring to the same model in your different like applications. Yeah, you can log different parameters, you can log different metrics, and you can even log artifacts. You can put like plots or confusion matrices or like a different version of your model, all of that on MLFlow. We use MLFlow model registry to kind of keep track of which model is the prediction model versus which is staging. So what that means, like downstream jobs can now just go and say, give me the prediction model for this forecasting thing, right? And that's it. We don't need to like worry about like version number or anything like that, because we can be sure that everything is consistently using the most up-to-date prediction model. Yeah, so that's basically this. And then MLFlow model serving kind of also gives you like a one-click deployment for a model. So you can it actually builds like the REST endpoint, and then you can just call the REST endpoint and then get recommendations off of that model. Yeah, so we talked about a lot of things. Now, how do we like combine all of this and then get to where we want to go? Yeah, so this is where the TF recommenders comes in Why it's important? Because TFRecords kind of make sure that Spark and TensorFlow are communicating in the same language, like the files are stored in the same format that's recognized by both of these ecosystems, right? So there is a library, I think it's from LinkedIn, so it kind of enables you to like read and write from a Spark data frame to a TensorFlow record. So you might have heard of other techniques like Petastorm, which kind of transforms a Spark data frame to like, TensorFlow dataset. But what you lose over there is like, you don't get that interoperability with TFX. So at some point, if you're like, I don't want to use Spark for this part of my job, I want to switch to TensorFlow, you now have the flexibility to do that because everything is modularized. So you read from TFRecords, you write to TFRecords. So that means like you can replace your Spark thing with TFX, or if you can replace your TFX thing with Spark. So you don't get that with Petastorm, so that's why reading and writing from TFRecords with Spark is pretty important. The other main piece is the TensorFlow Spark distributor. This is, again, part of the TensorFlow ecosystem, so it's in the TensorFlow GitHub repo, but basically it enables running TF distributed strategies inside Spark clusters. So what it does is it kind of delegates cluster management and communication within nodes, so you don't have to worry about like setting up environment variables and things going down and stuff like that. So another thing is you can also run on CPU clusters, but it's up to you. Like, do you really want to run deep learning on CPUs is another question. We found like 3x improvement in performance on GPU clusters. So yeah, it also supports custom strategies. So yeah, in the picture you can see like you have your Spark, the job, and then there is the Spark TensorFlow distributor, which kind of coordinates like the communication and everything between these different nodes in your cluster. So it is very straightforward to use Spark TensorFlow distributor. Basically, you define your dataset loading code and your model building code in a train method, and you just call the train method with this one line that says mirrored strategy runner, and then you just say run train. That's all you need to like convert your single node code to a distributed training code, right? So you can think of everything inside the train function is just your same single node code. So another pro tip is basically when you do TF distributor is like how does TF distribute works is it kind of assigns one node as a chief node and everything else as a worker node. Why you need a chief node is you don't want every single operations to be treated the same way, right? For example, if in your TensorFlow code you have like a callback that's actually, after every epoch, you're saving your model to like a persistent store. You don't want every single worker or every single node in your cluster to go and save it to the same location, right? So that's where the chief node comes in. So you'll be like, chief node can go write it to like S3 or some persistent store, while other guys can write it to some dummy location I don't care about, right? So you need to kind of handle that explicitly, but it should be pretty straightforward. You can actually find whether a node is a chief node or not by looking at tfconfig in the environment variable for that node. Yeah, another fun thing that we've learned the hard way is you might train your models for like 2 or 3 days, and then once you're done training, you'll realize that that's it. There's no way to retrieve our models back. So you need to actually handle model saving explicitly. So you need to define like a callback that goes and saves a model after every epoch. Because if you don't do that, because this whole thing is running in a wrapper, the mirrored wrapper, everything is inside the wrapper, so you don't get it back. You don't get the final model back. So you have to explicitly say like, say my best model, and then to this path. So this is something we learned the hard way because we trained for like 2 days and then we couldn't find the model. Another pro tip is callbacks itself can crash. So think of it like the chief node is writing a model to S3, right? But the other guys are just waiting around, and then they're like, okay, this chief node is not responding because it's writing the file, but it's not responding. So the worker is like, chief node is dead, so the whole training can crash. So what we did is like we just created dummy callbacks, which just does the same thing the chief node is doing, but to a dummy location, right? So it's the same thing, but if you look at the file path, it's just some random path. I mean, I don't care where you save it. All I care about it was what the chief node is saving, right? So yeah, so now you trained your model in a distributed fashion. You have it in MLFlow. You saved it in MLFlow. Now all you need to do is like use it in your pipelines, the inference pipelines, right? So for the batch inference pipeline, we can use pandas UDFs now. So in pandas UDFs, you just load the model you just trained, get it directly from MLFlow model registry. Just say, give me this deep learning model, the prediction version of this model, right? You load it into the pandas UDF on each of your nodes, and then use it like any other function in your Spark pipeline, right? So it's as simple as that. So yeah, you can see that line where it says with column, and it's actually going to do the whole lookup and run your data through the whole deep learning model, and then gives you recommendations in a data frame. This is something we use in production, so I can verify that it works. Some caveats over here is our models, because it uses TFRecords, it doesn't use the pure TF serving version, right? So we need a custom flavor of TF serving, which kind of bakes in the scan and index. So it's provided by Google, but MLFlow currently doesn't support it. It's in the roadmap of MLFlow to kind of provide like custom Docker images for serving. So hopefully, like in like a few months, like we'll get that capability. But because of that, we had to like create our own UDFs. It's not a big deal. Like you just use pandas UDFs. Yeah, so we talked about a lot of things. I'm actually doing better on time than I expected. So yeah, so as a recap, my whole proposal is to use like the best of Spark and TensorFlow, not stick to like one, because there is benefit on both sides, right? So yeah, as a recap, you can think about like your data ingestion stage where you read from your data warehouse or like Delta Lake or wherever, right? So you can use Spark to read from the data frame, data source. Then you do all of your feature engineering and build data pipelines in Spark, because if you're currently on Spark, it's better to just keep everything in the same location, right? But then once you're done with all of your feature engineering, you can now save it into your S3 or like some Delta Lake again, but as TFRecords, right? So what this means is now TFX or the TensorFlow libraries can read from this TFRecords file. So yeah, when you build the model, now the TFRecords are being read, not your Parquet files, but you can now read TFRecords and feed it directly into your model. So that part is pretty straightforward, because that's the recommended way of loading models into TensorFlow. So you can just directly pass a data set into the fit method. So it is very well integrated. Once you're done training, you can use a callback to save your model to MLFlow, and then you can use MLFlow model registry to look at certain metrics and figure out whether you want to promote a model to production or you want to just discard the model, right? So which is why we track all the metrics on MLFlow, so you can just compare the different metrics between different runs. Yeah, and then once we build the model, we have this inference job that runs daily. So for the inference job, you can build inference pipelines, which kind of loads your pandas UDF and everything into the whole pipeline, and then you can use and get recommendations. Yeah, so my final part is, here's like now we have your batch pipeline, but what if we want to unlock real-time streaming, right? So the good thing is we have all the pieces that we need. It's just about putting everything together. So why do we need streaming? So streaming kind of enables, like you've heard a lot of things about streaming in the past 2 days, but it enables a lot of exciting use cases. You can literally be in the same session with a member, right? So imagine the power of like you getting connected to the member as they're browsing through the site, and then you can make decisions like in real time. So for us, especially because we are this flash sale model, a big problem for us is like members coming in, looking at a product, and just leaving the site and never coming back. So that's where we feel like the streaming can be very powerful, because like with that just one product view, we can now give them recommendations, right? So it kind of unlocks a lot of real-time use cases. So this is just our prototype that we built. So we have three main components over here. One is our real-time inference service. Then we have the Spark streaming pipelines. Then real-time databases and APIs. So let me start with the Spark streaming pipeline. So Spark streaming can connect directly to like Kinesis or Kafka or wherever you're getting your data from. For us, it's Kinesis, and we connect our Spark notebooks directly to Kinesis using connectors that are already like there. And then you can actually process the raw stream, put it into like some Delta tables, and then do all of the feature engineering and all of these things that you need to do before you want to feed it into the model, right? So do all of that stuff in Spark streaming and Delta Lakes. Once you're done with that, now you create a UDF, which is going to call like a real-time lookup service, right? So this real-time lookup service can be on MLFlow serving, but because we had this issue with using MLFlow serving, we actually ended up building our own container service. So we used ECS and the Fargate to actually build that service. So what this does is this service is actually going to get the latest model from MLFlow, which is hosted on Databricks, but then it builds like a TF serving infrastructure, which kind of serves the model in real time. So all you need to do is like pass all of the data that you need to do prediction. So for us, it's the the members' previous views. So we feed in like this whole JSON with like what are the different products the member viewed, what are the different the name of the product, the brands and stuff, and then we feed everything into this JSON and we send it to this endpoint, and we get a list of products that we need to show the customer. So that's the whole real-time inference part. I rushed through a lot of things, but we can also use SageMaker, which we are also exploring for this part. But MLFlow serving should get there sometime pretty soon. All we need is the capability to like serve custom serving images. Yeah, and finally, like you would need like some sort of real-time database, because you would want to serve this recommendations to the the front end or like the storefront or whoever is actually showing the recommendations, right? So that's why we need a real-time database, and we use like DynamoDB for that. So we use DynamoDB, and we have like API gateways, which kind of serves all of the recommendations outside. So I think that's most of it. Again, to wrap up, some of the pros is this is more of a like DIY thing where you can. It's perfect for smaller teams who want to like build and explore different models and try to like test it before actually building a whole set of MLOps code and everything, and so spend more time on the research and ML part and less time on MLOps. So yeah, you can move from prototype production quickly. You can choose any framework. Again, like because we use TFRecords, you have the modularity to kind of swap your framework at any stage of the ML pipeline. So when you do feature engineering, if you want to switch from Spark to TF transform, you can do that. So that's the benefit of using this approach. Yeah, and then you can train it on GPUs, CPUs, and then you can use all of the goodness of TensorFlow and all of the goodness of Spark. So you can use any of the extension libraries. It's all the same. You might need a different Docker container to serve your model, but it's all available online. So that's, and then, yeah, we use MLFlow to kind of, make sure every downstream process is reading the same model. So it's very important because it's possible that, one of your downstream job is referring to model version 1 while the other thing is referring to model version 5, right? You want to make sure everything is reading the same thing. So there are some open challenges. Distributor training, like right now, if it fails, it doesn't have the gracefulness of Spark clusters where it automatically spins up a new one and puts all the workloads. So right now, if it fails, the whole training crashes. So you would actually need to save checkpoints. Yeah, and then the error messages are pretty cryptic, and then the APIs are changing and things like that. You would also need to find and tune the right amount of nodes for your cluster. You can use the TensorFlow profiler for that, but it's still like a bit of mix and match. So that's basically it. I have some links to the notebook, like a sample notebook where kind of go through these things, and then the slides also in this slide deck. So that's it. Thanks. Any questions?
Thank you so much, Ronnie. That was great. Were there any questions? I think we have time for one, just for the sake of time.
You spoke about inference and deploying the model. Are you able to capture both the data preparatory steps, transformations, and the model within a single file and then deploy?
So right now we don't. Right now it's like the same pipeline that we use for training, but the same thing for inference. So I think we would want to look into like feature stores and some of the things that were announced like today and yesterday.
Can you talk once more about how you deploy it, both transformations and?
Yeah, so we use Databricks. So initially when we do like our prototyping and everything, we would use like a single node like cluster, and then we just play with it. Once we want to deploy it, we just add those 2 lines of code, and then we just set up a whole Databricks job and workflow to orchestrate everything.